Hi guys, welcome to my channel. Today I want to start a new series, and I'll be this series is basically titled Probability Theory in Finance. And the reason why I want to start this series is because a lot of times when students from fields like applied sciences or engineering take up the subject, probability theory in finance or mathematical finance, they find it very hard. They It's because this subject particularly has a lot of abstract mathematics in it, which students from applied sciences or an engineering background aren't comfortable with because they usually haven't done it in their undergrad. So, the reason why I want to start this series is because I want to introduce the subject at a very intuitive and easy to understand level. So that you understand what's happening and what's going on. Now, that's not to say that this won't have a lot of mathematics in it. It will have a good amount of math, and that too at an advanced level. But the entire point is that I'll try to explain everything at a very intuitive and a basic level so that the foundations or the building blocks are very strong for a lot of students out there. Now, coming to the series, what I want to achieve with the series is that I want to start from the basics, which is set theory, and I want to introduce set theory in a measure theoretic sense. And with that, I want to work up all the way to the Black-Scholes formula. So that is my goal with this series, that I'm going to start with set theory. I'm going to develop all the theory and all the mathematics that you need to derive the Black-Scholes formula. And I'm going to stop there. I'm not going to go ahead to other models like the other models, OU model, CIR model. I'm not going to go to any of those. I'm just going to teach you enough math and enough theory that you need to to derive the Black-Scholes formula. Because I believe once you've done that, you can easily come to speed with the other mathematics or a little advanced mathematics that's required for the other stochastic models, right? So now that I've explained what I want to achieve with the series, here are little prerequisites that you need to be able to follow this entire series without a lot of effort, right? Otherwise, it will get hard for you because it will have a good amount of mathematics in it. So you should be very comfortable with classical probability and stats, at least at the undergrad level, the first year undergrad or the second year undergrad level. You should be very comfortable with this. And you should also be very comfortable with calculus at the high school level or um, again at the undergrad level, the first year undergrad or the second year undergrad level. Once the prerequisites are out of the way, this is what I want to achieve with this series. All right, I'll start with set theory, and I'll slowly introduce sigma fields, partitions, filtrations, information, measure theory, and measurable functions. All right, because this basically forms the building blocks of all your stochastic models, and without this first part, you're as good as lost. You won't understand anything. So I'm gonna spend a good amount of time on this, explaining why we need this in the first place. All right. After that, I'm gonna go to probability spaces, expected values, continuity, and integrability. All right. Now, again, depending upon where you're studying mathematical finance on different colleges, you will study expected values, continuity, and integrability at very different levels. If you're studying this subject at an undergrad level, you probably won't delve very deep into continuity and integrability. But if you're studying this at a graduate level, if you're doing some financial engineering program at, let's say, Berkeley has or Columbia's mathematical finance program delves very deep into the mathematics behind probability theory in finance. But I won't delve very deep into the hard math. All right, I'll only explain what's needed to derive the Black-Scholes formula, because again, I believe that if you understand the basics very well, you can easily get up to speed with the advanced mathematics that's needed for other stochastic models. All right, so I'm going to explain all of this, but to varying depth, all right? Because a lot of it is not needed for the Black-Scholes formula. Then I'm going to move on to conditional expectation, martingales. I'll try to deal with martingales at a very strong and deep level because martingales are very often asked in interviews. Or if you've done your financial engineering or mathematical finance and you apply for an interview at a bank, they will ask you a lot of questions from martingales and the theory behind them. And then I'm gonna derive the Black-Scholes formula, all right? And after deriving the Black-Scholes formula, I'm also gonna teach you a little bit of stochastic integration, which includes Ito calculus and Ito's lemma. Very important stuff. Like, I can't stress how important Ito's lemma is. This is extremely important. That's all I want to say. So again, when you're deriving the Black-Scholes formula or an option pricing formula, there are varying levels at which you can derive it. All right. So I'm going to deal with deriving an options pricing formula at varying levels, and yeah, uh, I'll I'll deal with four different levels of deriving the an options pricing formula. All right. So yeah. So now, before I end this video, I want to discuss why should we study this subject in the first place. All right. I mean, if you're going to go through all the trouble of studying all of this math, you need to know very well why you're doing it. Okay. So turns out that banks, all right, big banks with lots of money, well, they keep developing exotic products, lots of derivatives, all different kinds of derivatives, all right, because it turns out you can make a lot of money speculating on where prices are going to go. And I'm sure you know what derivatives are, that they basically, the value of a derivative is derived by the value of an underlying asset, right? So there are lots of derivatives. There's a plain vanilla option, right? There are American options. There are barrier options and binary options. There are lots of options, and all of them have different. They basically behave differently. They have a different PNL graph. All right. And the thing is, turns out that these big banks want complex derivatives and they trade using those derivatives because if they speculate on the prices of the underlying assets, and when the asset moves in a particular manner, either the buyer or the seller profits from it. All right. Now, why do you want to study the subject is that you have these different kinds of options. You have vanilla, American, barrier, binary, compound. There are lots of other options. But how do you price an option, right? Like, how do you decide if I'm a bank, how do I decide what price to sell it at to the seller so that, so that in a very ideal scenario, this option is neither profitable, is neither favorable to me, nor is the expected result of this option favorable to the seller, all right, the buyer or the seller. So turns out, well, pricing these options can get pretty difficult because options derive their value from a lot of things, right? Because let's say that this option derives its value from a stock. Okay. Now, now obviously, one of the things that the option can derive its value is from the movement of a stock price movement, right? How much has it moved in the past few days, and how much is it expected to move in the future? They can derive their values from dividends, that if the stock is paying any dividends to the shareholders, right? Because in that case, again, the value of the stock tends to change. It's decided by the the interest rate set by the federal bank, right? Because depending on what interest rate is set, the dynamics of the market can change, which in turn will affect the price of the stock. So options can derive their value on an underlying asset, and the underlying asset's value can be defined by a lot of factors. Well, these are just some of them. I'll delve into them deeply later, but I just want to drive home the point why we're doing what we're doing. So pricing these options can get a little complicated, right? And if there are lots of things that the option derives its value from, and these things tend to keep changing over time, pricing an option can get very complicated. So how do you price the option in a way that it's neither advantageous to the buyer nor is it advantageous to the seller? That means it's not favorable to the buyer, neither is it favorable to the seller. And that's exactly why we need all of this theory, uh, probability theory in finance, mathematical finance. That's exactly what we're trying to achieve. We're trying to price different exotic derivative products in a way that they're not favorable to anyone, neither the buyer nor the seller. So yeah, that's the reason why we are studying this subject. So I'll stop the video here, and I'll meet you guys in the next video. All right.